Hello everyone, myself Mohsin Khan. My presentation is directed weighted multigraph, understanding complex network. This is powerful structure in advanced graph theory used to model integrate real-world system across various domains. We explore how combining the properties of direction, weighted, and multi-edges provide the notions needed for complex network analysis. What is multigraph? Beyond simple connection, we start with multigraph. Its definition is simple. It allows multiple edges between the same pair of vertices, unlike simple graph. These multiple edges can represent different type of connections or multiple interaction occurring between two entities. This provide a more nonsense accurate representation of system where relations are manifested. Introduction: directed edges flow and influence. The directed nature add essential asymmetrical information. Directed edge is marked by arrows specifying the unidirectional flow or influence from a source vertex to a destination. This crucial or modeling moment or dependence such as information flow, data sent from server A to B, transaction, money or customer vendor or causally event X influencing. Weighting the edges, counting relationships. Weight transform abstract connection into measurable relations, adding quantitative context to graph weight and denote cost for value, time or duration or intensity or frequency, strength of communications. Why multigraph real-world application explore? The full value of multigraph is seen in their application. Transportation network model different road rail between location, each with distinct cost capacity. Financial transaction represent multiple type of financial instrument between institution. Communication system illustrate hidden or specialized data link between nodes. Key components, vertices, edges, and attributes. The core component of the robust model are vertices, edges, the directions, the weight. The combination of distinct attribute enable right detailed network modeling, representing multiple multigraph agency matrix and list. We have two primary way to represent multigraph digitally: the agency metric in 2D array, where the array will store total weight of count to edges from I to j. The agency list is more efficient for large space graphs. It maintains list outgoing neighborhood including entries for every parallel edges, and it weight choosing the correct structure in a vital for efficient algorithm execution, algorithm or analysis. The structure enable powerful analysis algorithm. Shortest path algorithm like Nakshatra must modified to consider directional flow and cumulative edges with central measure determine the most influential node. Cycle detection identifies closed loop which can represent feedback or potential boldness in system. Case study, social network and supply chain. In social network analysis, multiple directed edges represent different type of interaction with weight or frequency. In complex supply chain, the parallel edges represent different shipping method between warehouse, each with distinct time and cost weight. Multigraph provide the necessary detail that simple graph overlook. Conclusion, the power directed and weighted multigraph. In conclusion, directed weighted multigraphs are inseparable tool for sophisticated system analysis. They offer versatility across finance, logistics, and social science precision by capturing multiple directional and quantifiable relation and insight for optimizing prediction. Thank